Good morning, children. We proceed on to evaluation of limits. Question number 7. Limit x tends to 1 root x minus x squared by 1 minus root x. Substitute x equals 1 in this expression. See what I get. Root 1 minus 1 square by 1 minus root 1. That is 1 minus 1 by 1 minus 1, which gives me 0 by 0. That is an indeterminate form. Whenever I get indeterminate form, I should use some of the algebraic methods to avoid that indeterminate form. The problematic factor is 1 minus root x. Here root x minus x square. So how are we to avoid it? X square can be written as root x the whole power 4. X is nothing but root x square. So x square is nothing but root x square the whole square. That is root x power 4. Denominator I have 1 minus root x. The next step, I can take root x as common in the numerator. That is 1 minus root x cube. Denominator 1 minus root x. As we see, I can write a cube minus b cube. The algebraic formula, that is a minus b into a square plus ab plus b square. Here I have 1 cube minus root x cube. So wherever a comes 1, wherever b comes root x. Here 1 square plus 1 into root x plus root x the whole square. As I simplify, it is 1 minus root x into 1 plus root x. Root x square is x only. As we substitute, limit x tends to 1. Root x into 1 minus root x into 1 plus root x plus x. The whole thing divided by 1 minus root x. Cancelling 1 minus root x. And then let us apply the limit. Wherever x comes, I can put 1. Root 1 plus 1. As we simplify, it is 1 into 1 plus 1 plus 1, that is 3. So the given problem, limit x tends to 1. Root x minus x square divided by 1 minus root x becomes 3, and hence the problem is done. Question number 8. Limit x tends to 0. Root of x square plus 1 minus 1 by root of x square plus 16 minus 4. As I directly apply the limits, I get 0 plus 1. Wherever x comes, we put 0. 0 plus 1 minus 1 by 0 plus 16 square root minus 4. We get 1 minus 1 by 4 minus 4, that is 0 by 0, which is indeterminate. So naturally, we have to think of some algebraic reduction. We shall use the conjugate multiplication and division method. Because of minus symbol, I arrive at 0. Let me multiply and divide by the conjugate. What do you mean by the word conjugate? If I have minus symbol, I shall multiply and divide by the plus symbol. So root of x square plus 1 plus 1 we multiply and divide. What about the denominator? It is root of x square plus 16 minus 4. Again, it is a problematic factor. So what is the conjugate for this? Multiply and divide by that. X square plus 16 plus 4. Square root, remember to write. Root of x square plus 16 plus 4. So we multiply and divide. As I combine these two terms, it is a plus b into a minus b. That is a square minus b square. The left out term is root of x square plus 16 plus 4. Similarly, the denominator, I can combine these two terms, a plus b, a minus b. So how are we to write it? It is a square minus b square. And once I complete, write the left out term, that is x square plus 1 square root plus 1. And remember to write limit x tends to 0. As I simplify, I get limit x tends to 0. Root and square cancels. X square plus 1 minus 1. Denominator also root and square cancels. X square plus 16 minus 4 square is 16. Here I have root of x square plus 16 plus 4. Denominator root of x square plus 1 plus 1. Here 1 and 1 cancels. Here 16 and 16 cancels. We are left with limit x tends to 0, x square into root of x square plus 16 plus 4. Denominator x square into root of x square plus 1 plus 1. Again I can cancel x square. Now all the problematic factors, the negative symbols, the x terms got cancelled. We can substitute the limit. Wherever x comes, let us put 0. So once I substitute, do not write limit. So it becomes 0 plus 16 square root plus 4. Denominator root of 0 plus 1 plus 1. As we simplify, root 16 is 4 plus 4. Root 1 is 1 plus 1. That is 8 by 2, which gives me 4, and 4 is the limit value. Question number 9. There are two methods I can use. X power n minus a power n by x minus a. The numerator root can be written as whole power half. So I can write 1 also as 1 power half. Now I want 1 plus x minus 1 in the denominator. But x only is there. So add 1, subtract 1. Now it is of the format x power n minus a power n by x minus a. In the place of x, I have 1 plus x. In the place of a, we have 1. In the place of n, we have the power, that is 1 by 2. Check whether the limit is correct. We want 1 plus x to tend to 1. It is given x tends to 0. Add 1 on both the sides. So exactly it suits the formula. Let us apply. N is 1 by 2. A is 1. Half minus 1. 1 power half is 1 only. So my final answer is 1 by 2. This is one method applying the formula. I can do the same problem using conjugate multiplication and division. We have root 1 plus x by x. Multiply and divide by the conjugate. What do you mean by conjugate? Minus symbol comes. So we put plus up and down. And if I simplify, it is a plus b, a minus b. So it is a the whole square minus b square. Denominator root of 1 plus x plus 1 will come as it is, x as it is. As I simplify, it is limit x tends to 0, 1 plus x, root and square cancels. 1 square is 1. Denominator x into root of 1 plus x plus 1. Cancelling 1, I am left with limit x tends to 0, x by x into root of 1 plus x plus 1. Cancelling x up and down, apply the limit. When I apply the limit, do not write this. I am going to apply. Wherever x comes, I can put 0. 1 plus 0 square root plus 1. That is 1 by 1 plus 1, which is 1 by 2. The answer is same. Whichever method you prefer, you can adopt. Method 1 using the formula. Method 2 we have done conjugate multiplication and division. Can I directly do this problem without applying all this? Check. If I put 0, what happens actually? Root of 1 plus 0 minus 1 by 0. That is 1 minus 1. 0 by 0, which I call indeterminate. So direct application of the limit is not useful. I need to go by algebraic method, or I can go by formula method. Question number 10. Limit x tends to 1 cube root of 7 plus x cube minus square root of 3 plus x square by x minus 1. Wherever x comes, let me substitute 1. It is 7 plus 1, 8. The cube root is 2. 3 plus 1, 4. The square root is 2. Denominator 1 minus 1 gives us 0. Numerator is also 0, which is an indeterminate form. So we need to reduce either using formula or conjugate multiplication. Here, cube root and square root are given together. In such cases, conjugate multiplication will be difficult. So let us proceed to apply this formula, say x power n minus a power n by x minus a. When limit x tends to a, we get n a power n minus 1. We need to rewrite the given expression like this. Here cube root, that is whole power 1 by 3. Here square root, that is whole power 1 by 2. Both the powers are different. So we need to split the two terms. And I need a power n because it is cube root which is giving rise to 2. Let me add and subtract 2. As I add and subtract 2, plus 2 let me include with the second term, whereas minus 2 let me include here because we want minus symbol. If I take minus common, this also will be minus here. Here I have cube root. So 8 can be written as cube root to attain 2. Here I have square root. So which square root gives me 2? 4. So this 2 is written as 4 power 1 by 2. Whereas this 2 is written as 8 power 1 by 3. Now if I want to compare with this formula, I need these two terms in the denominator. But x minus 1 is coming here. What to do? What I want, let me multiply and divide. So 7 plus x cube minus 8, I multiply as well as divide. Similarly here, I want 3 plus x square minus 4 to apply the formula. So 3 plus x square minus 4, let me multiply and divide. As I simplify, limit for two different terms. What symbol is here? Minus. We have learnt a theorem, limit split for subtraction. So limit of first term minus limit of second term. For each term, according to my need, let me multiply and divide. Here I want 7 plus x cube minus 8. Here I want 3 plus x square minus 4. Now, this I want in the denominator. So this term I write x minus 1 here. Similarly, this term I need here. So bring this term here and x minus 1 here. Also, limit split for multiplication. So limit of first term into limit of second term. Similarly, limit of first term into limit of second term. As I apply this formula, let me check. Wherever x comes, I have 7 plus x cube. Wherever a comes, I have 8. What is the power? N is 1 by 3. So I can apply this formula for the first limit. What is the formula? N a power n minus 1. 1 by 3, 8 power 1 by 3 minus 1. Whereas the second, let me simplify. It is x cube, 7 minus 8 is minus 1 divided by x minus 1. For the second term, here wherever x is coming, I have 3 plus x square. Wherever a is coming, I have 4. And the power n is 1 by 2. As I substitute, it is n a power n minus 1. 1 by 2, 4 power 1 by 2 minus 1. But this is only for the first part. The second part I have to simplify. It is x square. 3 minus 4 is minus 1. Now, this let me simplify. 8 can be written as 2 power 3. 1 by 3 minus 1 is 1 minus 3, that is minus 2 by 3. Similarly, 4 can be written as 2 square. Half minus 1 is minus half. Now simplify this. Again, I can apply the same formula. Why? 1 can be written as 1 power 3. So what is the formula? Wherever x is coming, x. Wherever a is coming, 1. Wherever n is coming, 3. So if I apply n a power n minus 1, I have n to be 3, a to be 1. 3 into 1 power 3 minus 1. The same idea I can apply for this term also. Here, 1 can be written as 1 square. So what is the formula? Wherever x is coming, I have x. Wherever a is coming, it is 1. Wherever n is coming, it is 2. If I apply n a power n minus 1. So here n is 2, a is 1. So 2 into 1 power 2 minus 1. As we simplify, here 3 and 3 will get cancelled. Here 2 and 2 will get cancelled. We are left with 2 power minus 2. 1 power number is 1 only. Here 2 power minus 1. 1 power number is 1 only. Again, I can cancel 3 and 3. I can cancel 2 and 2. I am left with 2 power minus 2. 2 squared is 4. 2 power minus 2 is 1 by 4. 2 power minus 1 is 1 by 2. Taking LCM, it is 4. Here I have 1, here 2 2's are 4. So multiply by 2. As I simplify, I get minus 1 by 4. So we can conclude the limit of the given problem as x tends to 1. We arrive at minus 1 by 4. So it is quite a difficult problem wherein we have to apply a technique. We are using this formula because one power is 1 by 3 and the other power is 1 by 2. Accordingly, as I get 2, I add and subtract 2. But I need to write 1, 2 as a cube root of a number, another 2 as a square root of a number. Again, I cannot directly substitute because what is in the numerator should come in the denominator. So this bracket minus 8 should come. Here this bracket minus 4 should come. So what I need, let me multiply and divide. So these terms I want to use. So these two terms let me combine. Same way, these I want to use for the formula. So these two let me combine. Remember, limit split for subtraction, limit split for multiplication also. I can apply this formula for the first terms. This I need to simplify. Again, I can apply the formula for the second terms. Now everywhere we have applied this formula only. As we take LCM and simplify, we get minus 1 by 4. Question number 12. Limit x tends to 0, root of 1 plus x squared minus 1 by x. As I try to apply 0, it is root of 1 plus 0 minus 1 by 0. I get 1 minus 1 by 0, that is 0 by 0, which is indeterminate. So I have to choose an algebraic method to reduce the limit. Limit x tends to 0, root of 1 plus x squared minus 1 by x. let me use conjugate multiplication. 1 plus x square plus 1. Here minus is coming, so I put plus 1 as the conjugate. As I multiply, I need to divide also. Now, the numerator, limit x tends to 0. It is a plus b into a minus b. That is root of 1 plus x square the whole square minus 1 square by x into root of 1 plus x square plus 1. As we try to simplify the numerator, it is limit x tends to 0. Root and square cancels. I get 1 plus x square minus 1. Denominator x into root of 1 plus x square plus 1. As we simplify, limit x tends to 0. 1 cancels. X square by x into root of 1 plus x square plus 1. I can cancel 1 x and square. As I apply the limit, x becomes 0. Denominator 1 plus 0, the square root plus 1. 0 divided by 1 plus 1. Or I will say 0 by 2, that is 0. So the given question, limit x tends to 0. Root of 1 plus x square minus 1 by x is 0. Question number 13. Limit x tends to 0. Root of 1 minus x minus 1 by x square. As I substitute 0, I get root of 1 minus 0 minus 1 by 0. Root of 1 is 1 minus 1 by 0, that is 0 by 0, which is indeterminate. So we need to think of some algebraic reduction. Let me decide conjugate multiplication. What is the conjugate? Conjugate is root of 1 minus x plus 1. Whenever I multiply, I need to divide also. Now, the numerator is of the pattern a plus b into a minus b. A square minus b square. Denominator x square into root of 1 minus x plus 1. As I simplify, the numerator is root and square cancels. 1 minus x minus 1 square is 1. Denominator x square into root of 1 minus x plus 1. As we simplify, it is limit x tends to 0. 1 cancels minus x. Denominator x square into root of 1 minus x plus 1. Cancelling 1x and square, I am left with limit x tends to 0 minus 1 divided by x root of 1 minus x plus 1. As I apply 0, numerator is a constant, it is not affected by the limit. Denominator 0 into root of 1 minus 0 plus 1. This is 2 into 0 is 0. So I get minus 1 by 0, that is minus infinity. Now we will say as x tends to 0, we get f of x tends to minus infinity, and that is the answer. Question number 15. Limit x tends to a, root of x minus b minus root of a minus b by x square minus a square. As we apply the limit x tends to a, we get 0 by 0, which is indeterminate form. So let us multiply by the conjugate and divide by the conjugate. As earlier, the numerator is a plus b into a minus b format. So let us put a square minus b square. So the numerator is root of x minus b the whole square minus root of a minus b the whole square. As we simplify, we get limit x tends to a. The numerator square and root cancels. I get x minus b minus root and square cancels. I get a minus b. The denominator terms x square minus a square can be written as x plus a into x minus a. And the next term root of x minus b plus root of a minus b. As we see the numerator, minus b in between minus sign. So I can cancel b and b. I am left with limit x tends to a, x minus a, denominator x plus a, x minus a, root of x minus b plus root of a minus b. I can cancel x minus a term. I am left with just 1 in the numerator. Now I can very well apply the limit. Wherever x is coming, let us put a. X tending to a. So wherever x comes, let me put a. A plus a. Root of a minus b plus root of a minus b. As we simplify, it is 1 by a plus a 2a. Root of a minus b plus root of a minus b is 2 root of a minus b. As we multiply, 2 2s are 4, a root of a minus b. So let us take and write the answer. Limit x tends to a. Root of x minus b minus root of a minus b divided by x square minus a square is 1 by 4 a root of a minus b, and that is the final limit value.